All right, so the problem this time says you have a 100 milliliter volumetric flask containing 0.05 molarity of hydrogen chloride. A 2 milliliter sample of this solution was diluted to 10 milliliters. What is the concentration of hydrogen chloride in the dilute solution? Okay, so step one says identify given information. You're given that you have a flask, a 100 milliliter flask. I'll write that. 100 milliliter flask of a solution that has a molarity of 0.05 m and a volume, a 2 milliliter volume sample was taken and diluted to a new volume of 10 milliliters. Now you're looking for what is the concentration of hydrogen chloride in the dilute solution. So you're looking for concentration, another concentration, or another molarity. That is the point of all your work here. And I'll write the compound formula that you were given, HCl, and that's all you're given. So now it says apply the math or physical laws that relate to given information. You're given a molarity and a volume, and then you're trying to find a new molarity and you're given a new volume. So I will group these two and these two, and I'll call this initial, and I will call these your final. And well, when you're dealing with molarity, you know you're dealing with the molarity equation, which is m equals the moles over the volume. And similarly for the final, you have m2 equals the moles over volume 2. Now notice that I wrote m and v, and I wrote m2 and v2, but I didn't try and differentiate between the moles up here and the moles down here. The reason being is that it's the same moles. The amount of moles didn't change from going from the 2 milliliter sample to the 10 milliliters. I guess a good way to visualize what's happening in this situation is, let's say, rather than hydrogen chloride, we are dealing with iced tea. Someone at home made some iced tea, and it was so concentrated, they put so much mix in the water that it wasn't drinkable. And the amount of mix they put in there, let's say you have a concentration of 0.05 molarity. Okay? Now, you're going to take a 2 milliliter portion of this, and you're going to drop it into this new container. And you're going to fill that new container with water until you have 10 milliliters. So now you have a 2 milliliter sample of this that's concentrated at 0.05, and you dropped it into water and you filled it till you had 10 milliliters. So you have, in the end, a lower amount of iced tea in this new mixture because you have more water to iced tea. So the concentration may have changed, but the makeup of the iced tea itself, the powder, it didn't change. It's still the same iced tea in each one. It's just that there's more water to iced tea here, and there's more iced tea to water here, but the iced tea is the iced tea. The same thing here. The HCl is the HCl, or the moles of HCl is the moles of HCl. So you can use that and exploit it to eliminate moles from this equation altogether. And the way we're going to do that is because we have the molarity and the volume here, we're going to solve for moles. And you'll see why in a moment. Moles being your only unknown, you have moles equals molarity times volume. If you do the same thing here, you're going to have moles equals M2 times V2. Now, being that moles equals MV and you have moles equals M2V2, you can substitute either MV or M2V2 in for moles in either equation. I'm going to take this one and substitute it in for moles in this equation. So down here, after I do that, we'll have MV equals M2V2. Now looking at my givens, I have 3 of the variables. I'm only missing 1, and that's what I want to find. So if I isolate M2 in this equation by dividing by V2 on each side, the V2's cancel, and the new equation is M2 equals MV over V2. So now we have an equation that can help us solve for the second molarity. So we can't just plug everything in because in molarity it's in liters, but we were given our volumes in milliliters. So before we can plug everything into this equation, we have to do a couple of conversions. So first I'm going to convert the 2 milliliters, and 2 milliliters, I'm going to put it over 1. And now I'm going to find the relationship between milliliters and liters, because liters is what we want. So in order to eliminate milliliters, I'm going to have to divide by milliliters and multiply by liters. So 1 milliliter equals 0.001 liters. Milliliters will cancel, and after you multiply, you'll find that you have 0.002 liters, and that's in the sample, or I'll call it V. Doing the same conversion for V2, you have 10 milliliters over 1, and 1 milliliter is equal to 0.001 liters. Milliliters cancel, and after the multiplication you find that you have 0.01 liters. That equals V2. So now you have all your variables and you can plug and chug. So for M, or for the molarity, you were given 0.050. You're going to multiply that by V1, and we found that to be 0.002 liters. And we're going to divide all by V2, which is 0.01 liters. And after you do all of that, you find that the molarity of HCl in the dilute solution is 0.01. And that's it. The main thing to take away from all of this is when you list all your givens and you find that you have an original molarity and volume and then a final molarity and volume, and you weren't given a moles at all, you can see that from what we did here, that you can manipulate the equations to get rid of one of the variables. And if you're not comfortable with this stuff, I have other videos on molarity, and I hope I was able to help. Until next time, take care.